Hello everyone and welcome back to the Mentor Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Anvy, a lead data engineer. She will take you on a journey into the heart of Databricks Lakehouse, focusing on the incredible energy of Data Lake. Learn about storing data better and using it efficiently in the talk with Anvy. Now, before we dive into our session, I'd like to take a moment to ask you for your support in helping us grow our community and recognize our speaker. First, if you're enjoying the content we're providing and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below this video. Now, for something a bit special, in the video description below, you will find the link to the talk page where you can provide your feedback to this talk, give Envy a badge, and rate this session if you like or if you don't like it. Through the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box. Our team will be monitoring the chat closely and will collect all the questions to discuss with Envy after the presentation. And now, ladies and gentlemen, let's welcome our speaker to share her valuable insights with us. Envy, floor is yours.
Thank you, Alex and Data Science team for this opportunity. I welcome you all to this talk on Lakehouse Foundation. Today, I'll walk you through the power of Data Lakehouse. So, myself, I'm Anvy Elizabeth, a lead data engineer in EPAM. So, I have almost 10 years of experience in data. I have worked in Hadoop ecosystems, Spark, and currently as a Azure data engineer. And I have designed different data pipelines, like for supporting data migration as well as analytical projects, both on premise as well as cloud. I have experience in working with both streaming data as well as the batch data. So today's agenda will be like I will be introducing you to the story of a retail store where a use case of retail industry is explained to along with its data growth. Then different data architecture is used by the retail store during its evolution, including data warehouse, data lake, and finally the data lake house. And we can do what we can do better instead of data lake house. So it will be what we can do instead of introducing data lake house here, then the architectures of lake house, the principle to design a lake house, and how to build a lake house architecture in Databricks. And like finally, I'll be taking you through how the retail store solve their challenges using ACID transactions for reliability, Unity Catalog for data governance, and query performance for optimizations. So let us jump into the story of a retail store. So the story of retail store started in 1975 when they started as a single store. At that time, their only requirement was storing a billing transaction, and it is in structured data. So they just need a Excel or a OLTP database where they can store their billing transaction. But as their stores increased into different parts of the city, their business requirement changed. They need to gain business insights from their stored data. They need to get information like products that sold at highest demand, year to year at year sale, and there was that time also the data was structured data. But as in 2010, the years passed, the store developed and grown into different parts of the world along with their online sales. So this their business requirement changed. They had need advanced analytics like predictive analytics, customer satisfaction index, but along with that, they need to store structured and unstructured data like PDFs, emails, images, streaming data. So their requirement changed a lot by 2010. So now like we will go through the evolution of data architecture along with the store. So initially when they started, their requirement was simple. They used OLTP databases for storing structured data for storing limited online transactions. But as data grew to different parts of the city, they started their business requirement change and they want to do analytics on the data. So they used OLAP systems, data warehouses, where they store their structured data. They needed historical analysis. So their solution was data warehouse at that time. As again, like data grown in 2010 or after that, their requirement for structured and unstructured data landed them in data lakes, where they use data lakes for advanced analytics. Now, what is data warehouse? So data warehouse is an enterprise system where they store the data in structured format, and they will have a specific predefined use case for business intelligence and analytics. So they store historical data. So if you see here, they have to move the data from the external systems or to the operational data to the data warehouse. They has to do some sort of ETLs, prolonged ETL process. They will do curate the data and they move it to the data warehouse. Once the data landed in a data warehouse for predefined business rules, these are analyzed in business intelligence tools and reports are generated. As these are happening if in a requirement and basis, and data warehouses, like, they are highly reliable and they provide high quality business intelligence reports, and they are so reliable that business product owners or business end users can use the data warehouse efficiently. But the system has their own challenges. So first challenge will be like data warehouses has their own closed proprietary formats. So they their every data warehouse have their own format. So this will be a issue for coupling with other tools, like maybe a streaming analytics or a machine learning tool like PyTorch has, or any kind of tools coupling will be very difficult, or adding a new source data source in the future will be very difficult. And this introduce vendor lock-ins, like the data owner organization who are owning the data, they have to delay or they have to pay the data warehouse owners for getting their own data outputs or their own data reports from the data warehouse. And data warehouse supports only structured data, they have no supports for unstructured data. And there is no support for streaming, data science and machine learning workloads. So this was one of the main challenges that current systems face with data warehouse. And we know, like, today the data size is increasing day by day. So this, as the size of the data increase, the cost to scale out the data warehouse is very expensive, as well as the maintenance cost also started increasing exponentially. So these challenges made organizations to think of moving out from the legacy data warehouse systems to data lake. So what is data lake? Data lake basically is an open source system where you will be having a open formats, like open, you will be able to dump your data in structured, semi-structured or unstructured data. It can be images, streaming data, videos, PDFs, any of your data you can just dump to data lake, and it will be landed in the data lake zones. Once it is there, you can use your ETLs like what you used in data warehouse. You can use ETLs, move to data warehouse, then produce your business use cases reports out of it. Or you can prepare or validate your data using external ETL validation systems or validate data preparations tools to use it for machine learning and data science. So as the data is in open source format, open format, it supports any dumps. And second thing is, as your data grow, the data lakes also grow. It's scalable and flexible. And again, it supports advanced analytics along with the use of external tools. So these data lake systems also come with some kind of challenges. The first challenge is there is no schema enforcement or transaction guarantee or quality guaranteed for your data. So when you dump the data, it is in the native format. So if you have to analyze it, you have to enforce some schema on it outside, using outside tools. And as the data is having no any schema or structure, to the data management, lifecycle management, and data governance of the data is very difficult. It's become very complex, and as a result, the end product what you get here will be reliable. So if you have to add a new data source, you have to rerun your pipelines, you have to build your pipelines again, and you have to produce the data. So this will have quality issues and reliability issues of your end products. So these are some of the challenges faced by data lake today. So is data lake the final solution? No, because data lakes have their own challenges, right? As we see. So data, as the data grow, for example, when you load a retail store, load the data from into the data lakes and some partial failures happens, like a hardware failure or software failure happen, there will be a partial load happen to the data, but you have to do fixes on your pipeline, or to roll, there is no option to roll back your data. So this creates reliability issues. Again, like there is no data validation, this creates reliability issues. And at last there is no management of data, and there are like there will be lots of small files landing in the data, and there is no these small files can bring query performance because of input output reads, or continuous disk seeks will create low query performance. And there is a high cost of ownership. The reason behind, you will be have to pay for the data lake, along with that you have to pay for the external tools like ETLs, and along with that if you have to use a data warehouse for reporting, you have to pay for that. So there is a high cost of total ownership. And at last, like there is challenges for data governance, like there is not proper data security, there is in data like there is no way to track you the data lineage, there is no audit options, so access controls. So these all brings challenges organizations to use data lake. So what we can do better? So how what is a solution here? So it is that introducing data lakehouse. So data lakehouse is having best of data warehouse as well as the best of data lake. So it will be having the advantage, the quality, reliability of data of warehouse, the scalability, and the open source open format support of data lake. All these are clubbed in your uh, lake house. So in a lake house, you'll be have a data lake, and there will be a transactional layer over the data lake, built-in transactional layer over your data lake. So you'll be having built-in ETLs over there. You have your built-in validation tools over there, and you'll have a built-in query engines like over there, and you will be having a unified point where your end systems can query your data. So this is an architecture of a lakehouse architecture. So Delta Lake is an implementation of Lakehouse in Databricks. So here you can see this is open source data, like in open format data dumped into Data Lake. It can be low cost, directly accessible data lakes, and it can hold any type of data or any open file formats like Delta Lakes, Delta, or Parakeet, Abro, JSON, and streaming. It can be of images, PDFs, and like you will be having a transactional layer built over your data lake. So that is how Lakehouse comes into picture. Lakehouse add a transactional layer over your data lake, and it will make your data curated. It will provide metadata management to your system along with the data governance. And on top of that, you will have built-in high performance query engines, which will help you to do self-service of your data, and you can build your own data products out of it. And there is a unified platform for all workloads. So it is a single source for you to access the data, whether it's a report, whether it's a BI, it's a streaming analytics, machine learning, or data science. So you will be having a single point to access your data. So what are the principles for us to design a data lakehouse architecture? The first thing will be your data lakehouse should be uh, in such a way that it should democratize the creation of data. It should be self-service, that the user should be able to build their own product by themselves using simple queries, or uh, creation of Power BI reports, whatever it is. They should be able to do it by their own without creating additional solutions like additional ETLs or additional tools for that, so that it will be self-service at one. And there should be open source and support for open source and open format, that it should have support all types of data formats and all types of file types, or open formats like, or open types like. It should have support for files, images, PDFs, or any kind of file formats. And there should not be any data redundancy. It should remove data silos. Like you should not copy multiple copies of data should not exist in your system. So in as we see in data lake, the data copy of data exists in data lake. Again, one more copy exists in data warehouse when you do the reporting. So such removal of data silos happens in your data lakehouse. And you should have inbuilt query mechanisms which will be cost optimized as well as optimized query performance. Your any data lakehouse what you design should have this feature along with it, and your data should be provided as an end product from your data lakehouse. The end user should be able to use, just go take it and use it, that's it. So it should be curated in such a way that it could be provided as a data product. And the last, it should be a data governance. There should be proper data governance. But that organization wide governance should be there in your data lake. So it should apply all the standards like laws, all the laws, like if the nowadays all the organizations should follow GDPR or CCPA rules. So data governance helps this to achieve this. So a data lake should be capable of providing all kind of data governance. So this is how this slide shows how to build a data lakehouse using Databricks. So Delta Lake is an implementation of data lakehouse in Databricks. So here you can see we have batch data coming from the open outside system or streaming data. It can be any kind of images, pages, or PDFs. It could be any kind of data from the source, and you will be dumping your data into the raw ingestion layer or the bronze layer. So this is a kind of three-layer architecture. We call it medallion architecture, where the first layer is called bronze layer, second layer is called the silver layer, and the last layer is called the gold layer. So in the bronze layer, it's just a landing zone. You just dump your data. There is no schema, nothing. You just store your data here as it is in the source. And then comes your silver layer, where you define a schema to your data. You enforce schema to your data. So you will be cleaning your data, you will transform your data, you will filter your data. This is the layer where you will apply the transaction properties or ACID properties to your data. And it is the same layer where you can apply masking rules, PII rules, like for PII data, you can mask data. So all these things like can be applied on the silver layer. So mostly the silver layer data uh, provide access controls to your data up to row level. Whoever who can access each row of data, this can be defined here. And the end product end layer is a gold layer, so where you will be having a fine uh, business level aggregations on your data. So this will be absolute clean data, and that can be readily used by any downstream users or apps. And as you see from here, as you move from your source to your end product or any BI or machine learning tools, as you move from source to your end products, the quality of data get increased. So this is a showcase of how bronze layer look like. So this is, as I said, bronze layer is where you are dumping your data. So this layer, even you can archive the unprocessed data as a historic data for later use, or you can come back and see how your source data looked in in past. So here, if you see, we have different types of data. Paraquet data is the uh, data from event hub data, streaming data stored here, and you can have Avro data. There is a PDF stored here. There is a JPG image stored here. So this is a dump here, and you can see here. This is a Databricks Spark Databricks notebook, where I am using Spark program but to just read my data. So here you can see this is a Avro format. I'm just reading the dumped data in the bronze layer. I can get a view of what my data is there in the bronze layer. And here you can see the how an image was read from the bronze layer. It's just a reading of data. I'm not manipulating anything at the bronze layer. Here also I have just read the JPG image what is dumped here, and you can see all the points. From here you can further add the transformation. So that is what happening in the silver layer. So silver layer is the intermediate layer where the curation of data happens, validation of data happens, filtering, aggregations, and all kind of maskings happens at this layer. So here, this data can be used by machine learning models or SQL debugging. Any kind of um, downstream users can use this data based on the access control. So if you see here, I have applied some kind of filtering, a kind of transformation. So for this is the analysis done on a customer satisfaction. So I want to know the latitude of place from where the tweets was happened. So this some timestamp conversions. So all kind of transformations are main transformations are done on the silver layer, and also we are applying the some saving that upserts are doing at this layer, like for example, the combining of streaming data and batch data. So this is also happening here. So at this layer, I'm saving the data as a delta format. So the delta format gives your data the transactional properties. So if you see this silver layer, this is where my Azure blob storage is. So in my data is in turns stored in the Azure blob storage. That is my data lake, but it is stored as a delta format. So here your data will be stored as paraquet, but your transactional properties of your data, or the ACID properties, how it is attained, is using this delta log created along with the delta formats. So I'll be explaining you further on this delta format, or how the transactional features are applied in the further slides. Now comes the gold layer. This is the most curated layer as ready to consume data. So here the data will be, you will be having a specific KPI. So you will be producing your end product here using applying some more business aggregations or high level transformations on this data. This will be mostly only aggregations happening at this layer. So the users can directly use this data from here and create their own dashboard based on the sales KPI. So here the sales KPIs of a retail store, which will help them to derive business insights. So any business owners or end users can directly come, take the data in the gold layer, produce a dashboard or Power BI report, or even machine learning, in whatever it is, they can use it as a product, take it as a product and use it. Now I will explain you like how Delta Lake they address their challenges in the retail store. So we saw the first challenges was the data reliability. So data reliability was addressed using adding a Delta Lake, make your data lake transactional. So applying a transactional layer over your data lake, and creating Delta Lake make your data more reliable. So it data reliability means it is applying acid properties to your data. What is acid property? Atomicity, consistency, isolation, and durability. So in atomicity, we know like data will be, there will not be partial transactions. Either you succeed the data completely or it's failed completely. There is no partial transactions. And you will be having consistency. Your data is consistency is maintained everywhere. So for example, data from inventory of a store, data moved from one store to another. The total data in the other store should be the sum of existing data and what new data. At the same time, there should the balance in the store from which moved, it should be detected. So there should be consistency at the both place. And there should be isolation, means your read and write should be isolated always. And durability, so your data is, so in Delta Lake, the data is returned to your in a delta format to your layers like the data lake. So it's written to somewhere, so the durability or the existence of persistence of data is there. And with that, data reliability is achieved along with data validation and data enforcement, which is possible through Delta Lake. And also Delta Lakes helps us to do bulk updates and mergers and deletes. This also improves the reliability of your Delta Lake. So how Delta Lake brings transactional properties. So there is a transaction commit log called Delta log, which I saw earlier, which is saved along with the data, which has each and every changes you made in table is recorded in an ordered and atomic way. So if you read a data, so for example, initially you read two files, paraquet file 1 and paraquet. So it is stored in a delta log file called .json 00.json. And like in the second time you removed two files and added third file, so it will be added in the second delta log as a 001.json. So this is how transaction commit logs are added over the data, which make your Delta Lake transactional or acid complaint. So this is how multiple concurrent reads. So it isolates read and write. So for example, user 1 and user 2 is reading the JSON 00100 JSON. Both of them will see at the same time the same data in 00 JSON. But when 00 user 1 and user try to append something in 001.json, what happens? You applying some algorithm, data lake allow only one person to append it. But after this person is committed it, the second person will see the changes and he will be able to uh, change the uh, file after user one. But this lack of change is not seen by the user one or user two. There won't be any lag between user one or user two. So there will be a complete isolation between read and write in Delta Lake. And this is showcasing how upserts are happening. So how upserts are happening in a Delta Lake. So if you see here, I'm reading the data from bronze layer as first file. The first file is having a user called Nikhil and Bosch who will be having texted some their satisfaction about the customer service. But in the second file, Nikhil changed his comment, and at the same time there was a new user added in the file. So when I update or insert my data to my silver layer, the Nigel's data should get updated and the new user should get added. So this is how upsert happened here. So I have already shown the merge update command before, like how the upserts are happening here. So when we see what happens now, so for example, this is how there is a delta inside your data, there is a delta log file. For when you upload the first file, it will store the transaction as 00.json, where you see it will add the command like added the file Bosch and Nigel was added. This is the first transaction happened. So it shows just save the first transaction as 00.6. Second, I did the update. So what happened? It creates a new transaction file for 001.json for the uh, new upsert. So it will have a removal and add for the upsert happen and a add for the new person add new nickel got added. So this is how transactions can be seen in how Delta logs helps to maintain that each transaction has a commit log in the Delta lakes. And it also helps in enforcement of schema. So Delta Lake enforces schema validation on write and stop occurring writes when there is a mismatch. So for example, there should not be any strings data going into the integer format. For salary should not get tampered with any random string. So whenever if you enforce schema using Delta Lake, when you save the data, it will just throw error like, okay, your schema is not matching. So there are mechanisms to save these bad records to another locations or managing these bad records. But this is like you can just avoid unexpected issues with um, changing schemas. And next feature is schema evolution. So how there are some scenarios like you need to add a new column to your data. So if your business requires that as the time goes, you need to add new columns to your data. For example, a current month's column with the current month sales figure need to be added. Your delta lake should be eligible or should be possible, should have possibility to merge the schema. It should accept the change in schema. So there is a mechanism called merge schema which helps, option to merge schema which helps in schema evolution, the change in schema to accommodate. The other feature in Delta Lake is time travel. So we know we use code commit. So whenever there is a issue with your code, you can roll back to the old code with versioning. So same thing happened with Delta Lake time travel. So Delta Lake help or Data Lakehouse help you for data versioning. You can switch from different version of data set in a specific time period, and it helps you to attain data lineage, like it helps to understand you from where your data started, source and end product, also auditing of your data. So if you see, you can see I have done two inserts and a merge. So each of these are captured in your delta log file. Okay, it says shows your history. But when I did a merge, there was a issue happened. I want to ignore this session. So what I can do, I can query the timestamp from zero. Either I can use this version 01 or I can query with the timestamp. This timestamp I need to roll back to this stage of the data. So this is also possible with time travel in Delta Lake. And the next challenge, or how the next challenge with retail store is query performance. So Delta Lake address the query performance, that there when they dump the data to the bronze layer, there can be many small files which increases disk seeks or IO input output reads, which in turn increase the which creates query issues like query performance issues. There will be log queries. So retail store address this challenge using improving the query performance using Delta Lake. So Delta Lake has small file compaction option. It has the option for data indexing and data partitioning, and it has got a good data metadata management system. And when you do multiple data seeks from the data lake, it takes time. So it has options to cache your data, as well as it helps for data skipping. It avoids reading of some data to improve the query performance, which I can show you in the coming slides. So how Z ordering with compaction is obtained? So if you see, I have three files here along with the delta log file. These three package files are the, this is the delta file, my delta format, data stored in data format for the store managers. So if I use the command optimize with C order on the ID, so C ordering should be applied on your data with a high cardinality column. What happens? It will merge, compact, optimize will compact, do compaction. It will combine all your small files, and also the order will order your data. So if after compaction and C ordering, you can see like here the number of files added is 1 and number of files is removed 3. So it stores this stage of data. After compaction, what happened to your data? So it combined all the three. Not necessarily, it will not be always combining all the files. There can be multiple files, but here it happened, it combined the three files, so it got removed. Now you have only one file where you have the data from all the three files. So how data compaction is happening, and how the C ordering is working, and how data skipping is attained with this. So for example, you have this data like store 1, store 2, store 3, but you have to query where city is equal to Chicago. So when you do compaction, what happens? It combine the all the four files into two files based on some algorithms. And what happens? You see here the cities, Austin, all Chicago, all come. Some files come here and some files come here. But Chicago is not falling in here. You can see them if you order the data of city based on, for example, if I explain the ordering is based on alphabets, the maximum and max range and min range is not same in here and here. So what happens when you query the Chicago, it has to query in this file as well as it has to query in this file, because the max range falls in both files. So what happens with C ordering? So when you do a C ordering, the files are ordered based on the column city. You do a C ordering on city, so the files are C ordered on the column city. So what happens? The maximum range, the algorithm knows the maximum Chicago falls in the max and min range of the first file. So it can skip the second file completely. So the data to be queried minimized to only one file. So this is what called data skipping, that is attained with compaction and is a C ordering. And the last challenge, or the last challenge which I explained with retail store, is the query performance, sorry, the data governance issue. So the data governance is the system what should have in every organization. So with data governance, there will be auditing, will applicable access controls. So security will be maintained in your system. Data retention and data deletion. So currently there are GDPR and CCA rules existing in every countries for storing personal data as well as the other sensitive data. So there should be some mechanism to govern this. So data deletion and data retention should be governed, and there should be mechanisms for data discovery and also data sharing, because data sharing is another important factor that affect the data governance. And data lineage should be there in your data lakes, because you should not be able to view the lineage or the life cycle of system, where it originated your data and where it got entered. So this can be attained using Unity Catalog in Delta Lake. So Unity Catalog provides access control, user management, and metastore management. So before Unity Catalog, you have to separately maintain Databricks Workspace 1 and Workspace 2. You have to have a separate access control. There should not be a unified governance available. But with Unity Catalog, all your workspace you can maintain or manage at one place. So this is how the governance is achieved in his organization using um, data lake. So Unity Catalog is a huge topic which I'm not going deeply right now, but Unity Catalog helps you to attain governance in a, it allows you to apply standards for security, data lineage, and auditing, and all kind of governance in your organization. And there comes to the conclusion. So like as we gone through Delta Lake has how acid transactions bring Delta Lake with properties of combining streaming data and batch data. So right now data live tables are available which helps you to combine streaming data and batch data, and scalable metadata helps in Delta Lake for uh, uh, um, it meets the growing data requirements. So as your data grow, metadata also grows. So scalable metadata is achieved using Delta Lakes, and we also see how time travel helps you in auditing and versioning of your data. How Delta Lakes support upserts or deletions, or like how it supports the DML full DML support, and schema evolution, like how it is why it is required for the data quality, and how Delta Lake help you to achieve this. So that's it, like how the entire system of Delta Lake help the retail store to um, attain or achieve their business goals. Thank you. Any questions, please?
Yeah, thank you, Envy. Very detailed, interesting presentation. So let's move to our questions. Could you suggest some resources or courses to learn about Delta Lake approach and architecture?
Sure. So, Delta Lake architecture, the main source is obviously Databricks sites, where you will get very good detailed information about this. And there are Databricks community platform where you can practice your Delta Lake things. And there are Udemy courses which are very good with use cases explaining you about Delta Lake and Lakehouse architectures.
Mhm. And yeah, we also have a question from the chat. What happens to the data when it moved from silver to gold layer?
Yeah, when data move from silver to gold layer, data is more uh, curated, or it's all the high level business rules are applied to your data. And at the gold layer, at the silver layer, you can apply masking rules. So your end users, like a gold layer, there will be different type of users at the gold layer. You can mask the data from them. Also you can apply KPIs. Okay, your business KPI rules can be, business aggregations can be applied on your data at the gold layer. So your gold layer is a data product which can be ready to use. That's the difference between silver and gold layer.
Mm. And can, for example, be silver layer used to create multiple products? For example, different like gold layers.
Yes. You want an example? That's what you're saying. Like, what are the different products happened at silver layer? That's what the
Ah,
question is.
okay, okay, got it. Yeah, and yeah, you also explained this time travel feature. Maybe could you
Yes.
give an example where it really helps? Yeah,
Yes.
just maybe.
Yeah, so same as like your code. So you are your pipeline is upserting a new data. For example, till yesterday your data loaded to your Delta Lake, and today there was a upsert happened to your data lake, and due to some failures, uh, uh, there was some issue in the incoming data, and your data got corrupted. So you want to roll back to yesterday's data. This is how time travel helps you. You can provide the version of timestamp of yesterday or the version of yesterday, and you can simply roll back to yesterday's data without any issues, and you can reload today's data with changes.
So like, yeah, in case of failure, we can revert to the previous version, but maybe really some, I don't know, business use case when it can be used. Do you have something?
In a business use case, like some corruptions in your database, production database, some corruptions happened your database, and like database means your system, or when you load the data
Uh,
pipeline, failures can happen. So at that time you can roll back, right? That's the
okay.
production scenario what come to my mind right now.
Yeah, it looks like this data lake and data lake approach, and also this time travel feature. So it all creates additional files, and as I understand, so it requires more storage resources, right? Yeah,
Yes,
maybe
yes.
what
So
we can do
this
with it.
Yes, so that is why we are storing. For example, I have shown you how the delta logs are stored. So the commit logs are stored. These are stored in the data lake, which is cheap compared to any other storage. It's a blob storage of where which can scale to any size, and it's not. It has different cost layers also. Like if you want to store it at a low cost layer, you can store it that way. And there are, for example, you can after a long time, for example, after 30 days, you don't want the versioning of your system, you need to store only history up to 7 days, you can delete that all entire delta logs of your file, and you can just keep the time information or history of your data till last 7 days. So it depends upon your organization need, till what day you want the history, that's it. So that's how we can save your storage. If you are more concerned of storage, you can just delete it, or if you want to use a cheap storage, you can use it that way.
So it means that here needs to be some jobs that is executed regularly and do a compression of data, or
Y- Yeah, so there is option called vacuum, which can delete data from your delta lakes for particular retention days. For example, if you set the retention as 7, all the data informations which is older than 7 days, it will be vacuumed. It's completely deleted. This is how even this organizations are attaining they are maintaining GDPR rules or CCPA rules in their apply. They are maintaining this because there are in countries, many countries, the data is not, personal data is not allowed to store more than a particular days or months or years. So using vacuum, we can completely remove your data from your storage based on your detention period.
okay, yeah, got it. And yeah, I think that concludes our session. Thank you all so much for joining us today. We hope you found this session insightful and inspiring. In the video description below, you will find the link to the talk page where you can provide your feedback for this talk, give Anvy a badge, and rate the session if you like or if you don't like it. Additionally, if you want to revisit it, you can watch the recording on the talk page, and you can also download the presentation. So check the video description below. Thank you very much, Envy, for coming. It could not happen without you. Thank
Thank you. Thank you.
Yeah, goodbye.